Right then, so this is on low-level languages topic, and first thing is the addressing. So there are actually multiple different bits of addressing. So there's the immediate addressing, where data in address field holds the content needed by the program or the instruction. So it holds the data. It applies a constant to the accumulator. So the accumulator is a register. There's no need to access main memory. Index addressing, the address part of the instruction is added to the value held within the special register called the indexed register. I'll get that into a bit more detail on the index register after this bit on the index addressing. So the result is the required address. It takes a base address and applies an offset to it and fetches the data at that address. It is excellent now for handling data arrays. Now for the indexed register, use and purpose, so it stores number used to modify the address in the address field or data of an instruction. It is used in index addressing. It allows access to a range of memory locations. An example of this would be used to access the data within an array. Now, relative addressing, it tells the CPU to jump an instruction, so the jump instruction, that is a relative number of locations away from the current one. It is a very effective way of handling program jumps and branching. The direct addressing is used, which I'll get to a bit later down beneath this. So, but commences from start of the address of memory. The addressing begins from some arbitrary fixed point, and the real address is to be calculated for the base address and by the relative address. Relative address is an offset. It can be, and then the relative addressing, it can be used for arrays. Now, the direct addressing is a very simple way of addressing memory. The code refers directly to a location in memory. A disadvantage of the direct addressing though is that it makes relocatable code more difficult. Data in address field holds address of memory location whose contents are required. The index addressing takes a base address and applies an offset to it and fetches the data at that address. It is good for handling data on arrays. The data address field holds the address of memory location, which itself is holding the address of memory locations that is holding the values we want. Now, the difference between direct addressing and index addressing is that the direct is the simplest and most common method of addressing. It uses data in the data address field without modifications. It limits the memory location that can be addressed. An example of this is in add 23. Use the number stored in address 23 for the instruction. So then the index addressing uses the address field as a vector or pointer to the address to be used. It is used to address library routines. It increases the memory locations that can be accessed. An example of this is in add 23. If the address 23 stores 45, address 45 holds the number to be used. Alright then, so the next video on this topic is the mnemonics, opcode, and operand and opcode. Thanks for watching this video.